guys, welcome back. We are continuing. This is actually day 3 notes. It's continued. It's a second part on the characteristics. It's really just some more practice, and then we also include some slope over a given interval. So what I'd like for you to do, pause this video right now and do numbers 1 and 2, and then I'll come back and quickly go over them. All right, you should now be back from taking a little break and completing number 1 and 2. And the first thing that I want to do is on number 1, let's go ahead and just identify the slope. The slope is pretty easy to identify. All we need to do is pick 2 nice points on the graph. So if I have a nice x-intercept and y-intercept, I like to pick those. And we just need to count. Remember, slope is rise over run. So here we're counting that it's going up 4 and over 2. So if we put rise over run, we do need to simplify it, and we'll have a slope of 2. Okay. The reason I did that first, because that was pretty easy. Before I start and find all these other characteristics, I want to identify what the ends of my graph are doing. So this right side end is going up forever. Well, up numbers are getting bigger and bigger towards positive infinity. It's also going right forever. Right numbers, if you look on your x-axis and keep going right, those are getting bigger and bigger towards positive infinity. As we look at the other side, the left side of our graph, we see an arrow that tells us it's going on forever. It's going to go down forever. Well, if our numbers are going down and down, that's towards negative infinity. And it's also going to the right forever. Numbers that go left on our number line are getting smaller and smaller, so it's going towards negative infinity. I use those to help me with my domain and range, so I'm going to do that part first. So please remember domain, these are the x's, and they have to be smallest first, and then the big. So remember, that means look left, then look right. If you remember, we just had a left arrow and a right arrow, so we know as we look to the left, we're going towards negative infinity, and as we look towards the right, we're going towards positive infinity. Okay, so negative infinity to positive infinity, infinities, arrows, get parentheses. Okay, another way to say this domain would be all real numbers. So just make sure you understand that. The other part here is the range. Remember, these are our y's. So our range needs to be y's. Again, it's going to be the smallest to biggest. This time the smaller y's are down and the bigger y's are up. So that means look at my arrow down that we have. We got an arrow down here, and then we have an arrow up here, and we see that it's going from negative infinity to positive infinity. Okay. X-intercepts and y-intercepts, those are just where we touch across the x-axis. Please remember, these are ordered pair. For the x-intercept, the y is always 0, and for the y-intercept, the x is always 0. Okay, on our x-axis here, we see that we are intersecting at the x value of negative 2. And for our y-intercept, we see that we're intersecting at the y value of 4. Okay? With a linear function, if it's a straight line and it's always that same exact straight line, then that means it will either be an interval of increasing or decreasing, not both. So we're looking at this graph and we're saying, what is this overall doing? Well, as we look from left to right, it's going up, so that means it's increasing, it's positive. So for us, that means there will be none for the interval of decrease, but the interval of increasing will be every single x. So please remember, these are x values. So all of our x's are negative infinity to positive infinity. Okay. Now, for this one, it's pretty easy. If this is a straight line all the time, the slope will always be 2, no matter where we look. Well, let's just kind of double check that. If we go from the x value of negative 3, so that would be here, see how that's the x value of negative 3, and we go the x value of negative 2, that one's here, we could count that slope, and it's a rise 2, run 1, which is the same as the slope that we got before. All right, so let's look at number 2. You should already have this done. Okay, I'm going to start, let's cross off this slope because there are actually 3 different slopes to this graph, and that one's not a specific information. So our slope is not always the same. It's not constant here. Okay, so let's do our x-intercepts. We have an x-intercept here at -6, 0. We have an x-intercept right here, okay, at 2, 0. And we have another x-intercept over here at 7, 0. Okay. It's okay to have multiple x-intercepts, but you can only have one y-intercept. So notice here's my y-intercept. It's kind of covering up the numbers, so make sure you take your time and realize that this is at 0, 4. Okay. When we talk about the domain of this, remember I want to talk about the ends. This arrow goes left forever, and this arrow goes down forever. This right here was an arrow, and it is, I'm sorry, this was not an arrow, this was a dot. Okay, so it's not going on forever. So this is actually stopping at the ordered pair 7, 0. Okay, so I'm going to write that there because that's what's happening at the end. Okay, so our domain, remember this is the x's. So this is the x of the left side, and this is the x of the right side. So that means that our domain is going to go from -infinity to 7. Now, the infinity gets the parenthesis, but this over here, this 7, 0 point, that is an end point. So remember, end points get brackets. Our range, on the other hand, this is our y's. So here's the y on the left side, and here is the y on the right side. So this one is going to go from -infinity. Sorry, I should have said that's the y, the low. It's going down forever. Okay. But on this, we're not using, the right side. We are using the lowest, and because -infinity goes lower than this point, because that means this is just, I'll draw it so you guys can see it. This arrow is going to keep going down, so eventually it's going to be lower than this point over here. But where is the highest point going to be? The highest point is going to be right here at this y value, which is a y value of 4. Oops, sorry, I did not draw that 4 very nicely for me. Erase. 4. Okay, so we're actually using this highest y value, which is 4. Okay, and that is a point, so it gets a bracket. Okay, now for the intervals of increase and decrease, please make sure that you understand there are different places where this graph is increasing and different places where this graph is decreasing. So as we look from left to right, remember it's increasing if it's going upward from the left to the right. So that would be this piece right here. And also this piece right here. So these two pieces are our increasing pieces. The piece here in the middle is our decreasing piece. And if you remember in the other one, I said, let's go ahead and let's split these graphs so that we're separating the increasing pieces from the decreasing pieces. Okay, so we can say that everything on the left-hand side of this value at 0 is increasing, and everything from here to here is increasing, which this is the x of 5 and this is the x of 7. Then everything between this 0 and 5 is the decreasing section. Okay, so now we just need to be able to figure out how to write that. So our interval of increase is everything to the left of 0. So remember, the left x's are -infinity, and we're going to go to 0. And then also the other increasing piece, so we use the u to say that it's also this other piece, is from 5 to 7. Okay, sorry. And we said with our intervals of increase and decrease, we're always just going to use parentheses for now. Okay. Then the interval of decrease is the negative slope piece. Well, that's the piece in the middle, in between 0 and 5. Notice how that kind of fits in between the other two that we wrote for increasing. All right, now we're going to do the last part, which is the slope. These are x's, so from the x of -6 to the x of 0. So here is the point when x is -6. This is 0, so find the point, it's up here, and let's count the slope. So we're going to go up 4 and over 6. So rise 4, run 6, please reduce these, this is 2/3. Okay. All right, now that we've gone over those, this one here is asking us to graph the equation, so I'm going to help you graph it, and then I'm going to help you graph the next one, and then I want you guys to go find the characteristics and then check back. So let's graph this together. In order to graph this equation, we need to get it y equals mx plus b, so that means add 2 to both sides. Now we can see our slope is 1, and our y-intercept is at 0, 2. Okay, so our y-intercept is at 0, 2, and we're going to rise 1, run 1. So we're going to get a nice line. Okay, and I'll do my best to draw this nice. Okay, putting arrows on the end. If you draw it all the way to the edge of your graph paper, you do not have to put arrows because that's assuming it's going to keep going. If you do not extend it all the way, please make sure you put arrows. All right, now I'm going to go ahead and graph number 4. Okay, again on number 4, we have to get it. So it's in y equals mx plus b. So that means we want to get this piece alone first. So we're going to add 3x to both sides. Then we need to get the y by itself. So we're going to divide. This time we want to divide each piece individually because we want to clearly see what's the slope and what's the y-intercept. So y equals 3/2 is the slope times x plus 3, which is the y-intercept. So our slope is going to be rise 3, run 2, and our y-intercept is going to be at 0, 3. So plot your y-intercept, and we're going to rise 3, run 2. Rise 3, run 2. Go the other way, down 3, left 2, down 3, left 2. As far as you can go is my suggestion until you get to the edge, or until you get to as close to the edge. That way you can get the best line possible. So then you're just going to connect these dots because it's an equation, which means we can have the values in between these points. All right, so take a minute, go back and fill in all the characteristics for 3 and all the characteristics for 4, and then I will put my answers up. Let's run through the answers. The slope is 1, x-intercept is -2, 0, y-intercept is 0, 2, domain and range are both -infinity to positive infinity. So is the interval of increase. The whole thing is increasing. There is none for the interval of decrease, and the slope from -4 to +3 is 1. Okay. On number 4, we get a slope of 3/2, an x-intercept of -2, 0, a y-intercept of 0, 3. Domain, range, and the interval of increase on this are all -infinity to positive infinity. There's no interval of decrease because this is a positive slope, and the slope from -2 to 2 is still 3/2. Okay. This one is talking about someone named Mr. Fisher going on a bike trip over Labor Day weekend. Okay, so take a minute, go ahead, fill this out, and check your answers back with me. All right, you should be back now with these already filled in. Your domain is 0 to 6 with brackets because it's an endpoint. The range is 0 to 44 because those are your y's, and those have brackets because they're endpoints. Your x and y intercept are both 0, 0. You have 2 interval of increases, the one here from the time from 0 to 2, and then again from the time from 2 to 6. There's no decreasing, no negative slope. Sorry, I misspelled slope here. There is no negative slope pieces on this one, so none. Remember, max and min are y values, so y equals 44 and y equals 0, and then your slope as 0, 10,